Yeah? All good? Yeah? We're off. So, John Goodenough. Currently, I'm at the University of Sheffield, which was my alma mater where I did my PhD. This is the third time I've tried to give this talk, and I came to ask for help a year ago and failed to get here because I got caught up in a hurricane. And then I wanted to go to Latchup in Santa Barbara and got caught up in a thunderstorm and couldn't get on the flight. Thankfully, I came earlier to Valencia, so I'm here. And what I want to do with this talk is kind of engage with this community to sort of talk a little bit about curriculum, how I see open source tools could help, and some of the challenges then that we can all try and help each other with. If I do that, let me know. If I didn't, come and talk to me later. So I had a couple of motivations coming back into academia, and nationally, internationally, we all hear all of this stuff about workforce, and we also know that the cool kids don't want to do chip design anymore. They want to go and do software startups and AI and everything. So I came back to try to transform curriculum to actually deliver the workforce that the chip design, and I include in that EDA, IP, all the tools, and handoff to manufacturing, make that interesting, provide the people that the industry needs. There are far too few people coming back from industry into academia and bringing that knowledge and context back. So what follows really is a little bit of the kind of experiences I've had. I thought I'd take a minute first, though, to talk about what drove me to try to do this with open source. And I wouldn't have bothered if open source hadn't happened. Because part of the challenge of actually trying to teach chip design is it was getting really hard, and industry tier one wavefront and the complexity of what was behind the walled gardens. We've heard this a few times today about the know-how and the knowledge that's locked up in a tier one IDM or a big EDA company. How could we get that back into academia and then back into the next generation so they could innovate? That was the mission I came back to academia with. So specifically, I knew I couldn't do it without open source, but I'd been on the quiet engaging with the open source community in a variety of ways for several years. What drove me to give it a try, really, and we stand on the shoulders of giants. We've heard that a few times in the room today. Andreas with the POSH and IDEA programs, for example. But I actually felt that the tooling and the IP portfolio to teach chip design had reached minimum viable product for education. It probably didn't do that until almost maybe 3, maybe 4 years ago, and it's still a little bit clunky and there's work to do, but it was close enough to give it a go. Obviously, no encumbrance, no corporate terraforming across the curriculum. We're in the business of education, not training people on a particular tools or IP block. I'd also seen firsthand how the open source community in software mattered, and communities matter because they drive engagement. And if we want to get people engaged in chip design, we needed to build on top of an open source community that let people engage, self-help to build their own confidence and knowledge. And also, if they've got something they can use, the best way of driving things through it is through some sort of semi-competitive competition. I'm sure Olaf will come up with his core mark 3 or 4 times through the course of the conference, but that actually is a good thing, and that motivates and inspires young people to get engaged. Being open means that I don't know what I'm walking into, caliber of students, delivery environment, different universities, and we'll come back to that a bit. I can adapt to the assets. I'm not going to have to go and ask someone to do it for me. I can be agile. Also, we'd seen, web delivery, super good. I can inject a lot of micro-learning moments into curriculum. And, of course, we're already using it in software engineering. Anybody teaching in computer science was teaching open source software and Linux and operating systems anyway. Why not translate it over? Why I think we needed to do it as well, and my other motivation is we need to get ahead of the coming AI wave in design. It's going to happen. AI for engineering, soup to nuts, it's going to happen. The kind of closed source industry was kind of blocking us from getting ahead of that and promoting disruptive workflows. So that's what drove me to give it a try. Some things I then found out. I came from industry. I've been in industry. I started out as an academic. I stopped lecturing in 1992 to give you an idea, and came back in 2022. Being a faculty member, not the industrial advisory board. Shit. You actually have to deliver curriculum. There's an employability objective as well as doing open source. I hadn't really comprehended that the students wanted the CV tick box, so they need to use VCS and Cadence and the Cadence suite so they can fill their CV up. Surprisingly, not everybody wants to do chip design. There's an 80% of the cohort that you're putting through that don't care. There's also a wide variation in student capability and capacity that you have to deal with. There's the foibles of anybody who's teaching will know of assessment and accreditation to go through. You can't just put a course together. You have to get it signed off. You have to think about how you're going to examine things. And everything in academia is being done on a shoestring and last minute, so you've got to be hyper adaptable. So in doing this, quite complicated. We've started as well in Sheffield looking at what we're trying to do. So we heard earlier from Thomas about, okay, how am I using open source to build a product sort of thing? How can I use it? I'm doing, what is my product as an educator? And my product actually is delivery of a number of programs over a number of years. It's direct entry at masters, it's direct entry from overseas students. We have different semester structures. We have modules that we complete in one semester. We have modules that we spread over two. There's a lot of choices for what you do and how you approach it. There's also, what is the outcome that you're trying to deliver? What do employers want? A lot of work being done out of SRC in the States on things like key skills and ability matrices. ARM also has one of these. On the left-hand side, what's the entry? What's the experience at entry? Have people done an A-level if we're coming from the UK in maths and physics? Do they go through a triple ECS pipeway, or do they go off and do physics and come back and take a course in VLSI design? So there's a lot of things to think about. And for those of us who are in academia, we also have to think about how much does it cost to do all of this, and how much revenue am I getting from the product, either investment from my state and government, student fees, or other things, because I have to employ an academic workforce to deliver. So you have to come up almost with an architecture for how you deliver curriculum. We do computer architecture. Here's a high-level architecture of curriculum. So a couple of experiences and challenges here, and I just want to sort of spotlight. There's the rest of my team from the Microelectronics Systems Group are here down from Sheffield. They can also answer these questions and can answer all of these questions way better than me, because I'm doing that higher level architecture. I'm doing some of the delivery, but not all of it. So we had some really good experiences based on some of the assets. We adopted the RISC-V FPGA ecosystem, and we found that really, really good for supporting both teaching on undergraduate projects in curriculum for design exercises and supporting master's projects. We've adopted tiny tape-out, particularly into co-curricular activities, not necessarily mainline in curriculum. We've discovered that language localized learning materials are critical if you're bringing in an overseas student cohort to kind of keep the lights on and have an educational product. We've also discovered that what we've called browser moments that we can put into curriculum, where you can show people something happening in a browser window without having to start up an environment, very, very useful. So things like SillyWhiz we've found good to deploy in there. Challenges on the right-hand time, I kind of boil these down to two. You're running any business, it's cost. right? There's two costs. One, the students are paying you to come to university, or certainly they are in the UK. Again, your mileage varies in different countries. And also there's the cost of delivery to deal with. The other thing, computer screens are boring. People want to touch things. We are living in a world where we need to try to create more visceral experiences around chip design, however we can. So these are the sort of things we're trying to sort of build on, and my team's been great working with me on this. I don't think they knew what was in store for them when I arrived, and maybe they're now only realizing they've been part of a large number of experiments in applying these open source assets all over the curriculum. So what next? And this is kind of this is the invitation to follow up, to talk, to chat to us. So what are we doing immediately next year and through the next academic year? Joachim and I have already been talking about this. We're going to actually do an integration of GDS Factory into our undergraduate clean room. So we have a clean room that we open to undergraduates. We're trying to go through a whole design, make, build, test cycle where you get your hands dirty. It's not just an FPGA. It's not just in simulation. We're going to be writing, and I'm looking at Mohammed here, a new module in modern verification. Quite a lot of EEE and ECS programs, they don't teach test and verification at all, anywhere, ever. And most entry-level jobs, when you go into the industry, they're all about writing benchmarking software and test and verification. So why aren't we doing that? We want to experiment with some tape-out programs. So something using tiny tape-out in the undergraduate curriculum, targeting IHP with some RF chip designs and Chip Foundry, if it continues to run. We also have been chatting a bit to Matt about this, and reminds me that we still have to arrange when we're going to do this. We want to do a two-step, not just a tiny tape-out, but the follow-up, bring-up, and try to create a sequence of those events. Per that architecture, we're revising the curriculum. Anybody who's thinking similar has thoughts, I'm all ears. And if you're thinking of doing anything, whether it's summer schools, co-curricular things, then please come and have a chat. We could provide a test bed in Sheffield to try your ideas out, or we can collaborate on course content. Thanks for your attention.
Hey John, great talk. Thanks so much. It's a really good perspective, I think, from the perspective of someone setting the curriculum for undergrad courses, to hear the challenges and the successes of using open source IP. I love to see what you're doing. Do you think you've been successful overall? Have the efforts been fruitful, do you think?
Yes, and I think particularly what I'd say, I was really unsure how far I could go with computer architecture practically rather than just theoretically. And when you anchor that in basically something like RISC-V FPGA, you can do a lot. You can cover a lot of computer architecture and microarchitecture very effectively through those assets. As I say, you then realize where's the verification and also where's the VLSI implementation. Right, so those are the things we've got to fill. Those are the things we've got to fill in. I think they're harder, and then next, where's the analog? Yeah, that's pretty much the answer I get when I ask that question. Yeah.
Hi, thanks for the talk. I was just wondering, how do you connect with other universities? I know like there's the Edu4Chip project which is doing maybe similar things. I think it's just starting now, like this October. So yeah, we're ahead of it. But I was just wondering, do you do it all by your own, or do you cooperate with others as well?
Yes, so I'm here. So it's partly do. So the EU4Chip, so I'm from Britain, if you haven't noticed. We're not in the EU anymore. So there's some challenges in joining in some of the European initiatives directly. But I was actually up at Tampere the week before last talking to, if people know, Ari Kamala up there, ex-Nokia chip designer, aligning what he's been doing up there at Tampere, and he's a key part of that program. So yeah, we can only do this together. It's like the open source thing. we need to start sharing experiences. You know, we have to customize them to the locality and the semesters and the delivery constraints and the operating models of the institutions. But yeah, only together can we do this.
What should be an optimal turnaround time from a fab, from your point of view?
5 minutes. So it's a really good question, because you know, we was chatting to someone about this.
Can we manage this?
Sorry?
IHP?
We'll see next
Yeah. Chatting about this. I mean, you know, minimum fab cycle time is probably realistically 3 to 4, 5 months. If you use something like, you know, interesting things like pragmatics, so Emre's in the audience here, we've had conversations, could you drive a faster cycle time? There's some challenges aligning timescales of fab runs with the delivery, your curriculum delivery, so you can fit things. You know, there's actually a real scheduling problem, so you don't miss. You know, you even I was talking to Bora Nikolaevich at Berkeley about this last time I was over, and they have a problem in that people will do their tape-out class and then never come back for the bring-up. So you know, because what are you trying to do? It's kind of it's challenging. It's challenging. But yeah, as quickly as possible.
Definitely good discussion for tonight also.
Yeah.
Let's thank John again.